Okay, I want to share with you today something that you can use, a tool that you can use during engineering design to help you in finding a design solution to a problem. Now, in this particular example, we're looking at a particular component on a race car, in which we have two different design solutions. In this case, either design 1, a front monoshock, or design 2, a separate rear bell crank. Now, in order to help us decide which solution is the best or the most appropriate to solve the problem, we can identify the attributes or the aspects which are important to design. So, for example, in this case, mass, cost, reliability, how reliable it is, serviceability, so for example if it's going to be maintained, how easy is it going to be to service, the performance, the manufacturability, and by this we mean how easy and efficient is it going to be to manufacture, and the aesthetics, how pleasing is it going to be to the eye. Now, for each of these attributes we identify a weighting factor. So for example, the mass of the design, we've identified a weighting factor of 2, which shows it to be more important than, say for example, the aesthetics, which has been defined as, the weighting factor has been defined as 0.5. It's important that all these weighting factors add up to a total value of 10. Now, for each of the designs we rate out of 10, so it's 1 out of 10, 10 being the best and 1 being the worst. So for example, if we look at the serviceability for the front monoshock, we've given that a 5, which means that it has a reasonable serviceability to its design. However, the aesthetics has been rated a 9, which means that it's very aesthetically pleasing to the eye, which is good. Now, just a word of warning on here. If, for example, the mass, okay, now we want the mass, this being a race car, the mass to be as light as possible. So, therefore, for a very, very, very light component, we identify a very, very high value. So here, a 7 or an 8 would be a very light a rating. So what we can do then is use Excel. I mean, this has been generated, this table here, in Microsoft Excel, because we need to do just some very simple calculations here. So effectively what we've done is we have calculated the scoring for each item for each design multiplied by its weighting factor. So for example, here we have the front monoshock at 7 multiplied by 2 divided by 10, which gives us a value. Now we add all those up to give us our rating, our total rating of 7.2. Now we do that for all of the designs, then we come up with a total value, and this value we can use to compare designs. For example, in this particular example, we have the front monoshock in terms of numerical data providing a better solution than our design 2, the separate rear bell crank. So this can help to work out which solution is the most appropriate for solving our problem. Just a word of warning on this: all of these values here are subjective to the group of people or designers rating them. So one group of people may define different values to another group. So it's important to, if you're working amongst the team, to come to a consensus on the values. So I hope that helps, and all the best.